How does the DAI stablecoin work? This is a question that I had, and to answer my own question, I first looked at the DAI stablecoin contracts. But I quickly ran into the problem of not understanding the code, and one of the reasons was because of the weird naming conventions. For example, if you look at the contract called BAT, then we have some state variables like wards, alt. Going down, we have other state variables like can, and functions like hope, nope, and wish. Furthermore, we have a struct called ILK and yearn. And this weird naming convention is consistent throughout the contracts for DSS. DSS is the GitHub repo for the DAI stablecoin contracts. So this will be a video series on rewriting the DAI stablecoin contracts. In this video series, I'll rename a lot of the state variables and functions in a way that makes sense to me. And I hope that it will also make sense for you. And to begin with, in this video, I'll go over how all of the DAI stablecoin contracts work together to create the DAI stablecoin. The first thing that we need to understand is called a CDP. It stands for Collateralized Debt Position. This was the name given to the first version of DAI. And in the second version of DAI, the multi-collateral DAI, this CDP is renamed as bolts. So CDP and bolts, they both mean the same thing. And what CDP is, Collateralized Debt Position, to mint DAI, you'll need to put in some kind of collateral. For the purpose of this video, let's say that the collateral is ETH. So when you put in ETH as collateral and then mint DAI, then you've created a CDP. To put the collateral into the DAI stablecoin system, the first contract that we'll need to interact with is called gem join. This is a contract where the collateral is locked, and when the user exits the DAI stablecoin system, this is also where the contract that releases the collateral. Once the collateral is locked into this gem join contract, it will call into the back contract. This back contract is the core contract of the DAI stablecoin system. It keeps track of how much collateral each user has put into the DAI stablecoin system and how much DAI that the user has borrowed. It also releases the collateral for liquidation to other contracts. We'll come back to this later. So once the collateral is locked inside the gem join contract and this information is stored inside the back contract, the next thing that the user can do is mint some DAI. They'll first need to call the back contract to create a CDP, and once they do that, they can mint DAI by calling the function DAI join. DAI join is a contract that is responsible for minting and burning DAI. Now a user can directly call into the gem join contract, the back contract, and also the DAI join contract to lock collateral and mint DAI. However, this is a little bit tedious, so there's a proxy contract where it batches all of these transactions. A user will create a proxy contract and then execute some code inside the proxy actions. This contract will handle calling into the gem join contract, the back contract, and the DAI join contract. Now there's another helper contract called a CDP manager. This contract is useful if you wanted to create multiple CDPs and then maybe later transfer ownerships of the CDPs. Once the collateral is locked inside the DAI stablecoin system and a user mints DAI, how does the DAI stablecoin system know how much the price of the collateral is? Well, this is the responsibility of the contract called spotter and pip. Pip is a price oracle where the price of the collaterals are stored inside this contract. Once the price is set inside the pip contract, this price is fed into the spotter contract, which will call into the back contract to set the price of collateral. So that is how the back contract knows the price of the collateral and whether a CDP is in good position or whether the CDP needs to be liquidated. A CDP that needs to be liquidated means that the price of the collateral has fallen, and now the user has borrowed more DAI than the value of the collateral that is locked inside DSS. When this happens, when the value of the collateral is less than the amount of DAI that was borrowed, this CDP can now be liquidated. And this is the responsibility of the DAI contract. The DAI contract will initiate a liquidation. The amount of debt that needs to be covered by the liquidation will be stored in a contract called the BAO contract. This contract will store the debt and any surplus that is made by the DAI stablecoin system. The current mechanism for liquidation is by a Dutch auction, and this is done by calling into the Clipper contract. The Clipper contract starts a Dutch auction. A Dutch auction is an auction where the price of the item to be sold is initially set at a really high price, and this price gradually decreases over time. When the user thinks that the price is right, they will buy the item and the auction ends immediately. So the Clipper contract will do a Dutch auction for the collateral. The user will receive the collateral, and in return, they'll have to pay with DAI. This DAI will cover for the debt that needs to be repaid. Once the debt is repaid, this will be recorded in the back contract. Now earlier I said that there's also a surplus for the DSS, the DAI Stablecoin system. So where does this surplus come from? Well, the surplus comes from the interest when you borrow DAI. So when a user creates a CDP, they lock in some collateral and they mint DAI. What they're actually doing is they're borrowing DAI, and over time this DAI will accrue interest. The user that borrows DAI will have to repay the DAI with some interest. This interest is the surplus that the DAI stablecoin system makes, and this is recorded inside the BAU contract. When there are enough surplus that is made by the DAI stablecoin system, it will initiate a surplus auction to sell DAI and buy back the governance token called MKR. The surplus auction is called a flapper. And what the surplus auction will do is it will sell DAI and then buy back the governance token MKR. Another responsibility of the BAU contract is to initiate the debt auction. So what is this debt auction? Well, going back to the liquidation, let's say that a liquidation of the collateral was initiated. However, for some reason, no one wanted to buy the collateral. In this case, the whole system has created a debt that cannot be recovered. It cannot be recovered since no one wants to buy the collateral. And in this case, the debt that was created inside the DAI stablecoin system must somehow be recovered. And this is done by the debt auction. The debt auction will mint MKR, sell MKR, and the users will try to buy the MKR and then pay DAI into the DAI stablecoin system. Sell MKR by minting more MKR, and the user will pay with DAI. This is how the DAI stablecoin system tries to recover from a debt that failed to be recovered from a liquidation. And the last part of the DAI stablecoin system is the jug contract and the pot contract. Let's start with the pot contract. So remember that the borrowers of DAI have to repay interest on the DAI that they borrowed. When they repay, part of the interest will go to the BAU contract, which later will be sold out as surplus auction, and the other part of the surplus is used by the pot contract. The pot contract is like a savings account for the DAI stablecoin system. Holders of DAI can lock their DAI inside the pot contract, and in return they will earn some interest on the DAI that they locked. Now you might have one clever idea where you will borrow DAI and then put this DAI into the pot contract to earn interest, but this will not work since typically the fee to borrow DAI is greater than the fee that you will earn by locking your DAI inside the pot contract. The last contract that we'll take a look at is called a jug contract. What it simply does is it calculates the new interest rate and then updates the interest rate inside the back contract. So that's the core contracts for the DAI stablecoin system. In the following videos, we'll recreate these contracts and then rename some of the state variables and the functions. And hopefully you'll have a deeper understanding of how to create a stablecoin. Thanks for watching and see you in the next video.